Prove by induction that this is divisible by 4 for all n element n, right? P1, step 1, 9 1 minus 5 1 equals 4. 4 divided by 4 equals 1. True for P of 1. That's 5 out of your 20 marks right there. Okay, second thing, once you've done that, I haven't got enough space, so I'm just going to space out premium here. Next one is P of k. P of k equals 9 to the power k minus 5 to the power k. Right, and you always say assume true. That's another 5 marks. You're on 10 out of 20. Okay, prove for P of k plus 1. Now guys, what I always tell you guys about these ones is you're going to bring it back to the language you did there. Okay? So you break it up into 9 by 9 to the power k minus 5 by 5 to the power k. Everybody happy with this? Now, what you always do is you're looking to make some multiple of that. Okay, so you're looking to make a multiple out of that. Okay, so what I can do here is I can make 5 times that amount. So I'm going to break up the bigger number. The bigger number always breaks up into the smaller number. So it's going to be 4 plus. So it's going to be 4 plus 5, because that makes your 9. So here's what I'm going to do: 4 by 9 to the k. Then I'm going to have plus 5 by 9 to the k. That makes your 9 to the power 9k. And then I have minus 5 to the power 5k. Now, if you look at this, guys, I can factorize out the 5, and you get 9 to the power k minus 5 to the power k, and then you have 4 by 9 to the power k. Now, what's your reasons here? 4 divided by 4 equals 1. Yeah? And what about here? Assumed true by P of k. And what's the big long spiel you write at the end? Am I saving myself a bit of time here? True for P of k plus 1. If P of k is true, hence by the principle of mathematical induction, P of n is true. Everybody knows that one. It's just getting there is the problem. Okay, everybody happy enough? Any questions? Okay, this next one caused a bit more hassle than it should have. Let me explain why. It's a series question, which means that this series here, the sum of all the n squareds will give you this here. Okay, so let's prove P1. Prove P of 1. So you're going to get 1 squared, because remember it's like T1, T2, T3, and on this side is Sn. So when we insert T1 in, we're basically proving that T1 equals S1. If we were to put in 2, it would be T1 plus T2 equals S2. Do you remember the series? The first 2 terms is S2, adding the first 10 terms together is S10. Okay, so all we have to do is prove P1. Okay, P1 equals 1/6, 1 plus 1, 2 times 1 plus 1, all into the calculator. It's going to be 1 equals 1. True for P of 1. Everybody happy with that? Okay, 5 out of 20 again. Move on from there. Assume true for P of k. Okay, and when you assume true for P of k, you're going to get 1 squared plus 2 squared plus 3 squared plus dot 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 k squared equals k over 6, k plus 1, 2k plus 1. Everybody happy with that? Now, next thing is proof for P of k plus 1. Now here's the tricky part, okay? P of k plus 1, we're going to start on the left hand side. 1 squared plus 2 squared plus 3 squared plus dot 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 k squared. This k squared is tk. Would everybody agree with that? It's the kth term. Okay, because t1 is 1 squared, t2 is 2 squared, the third term is 3 squared, the kth term is k squared. So we're now looking for the k plus 1 term. which is going to be k plus 1 squared at the end. Okay, I'm just going to put this in a little square bracket, you'll see in a second. Now, after doing that, what we're going to do next is, make that a bit smaller there. What we're going to do next is we're going to replace, any k I see has to be replaced with k plus 1. K plus 1 over 6, bracket k plus 2, because I'm replacing this k here with k plus 1. Now it's going to be 2 times k plus 1, which is or 2k plus 3. Now, my job is to show that the left hand side equals the right hand side. Is that alright? Okay, so left hand side equals the right hand side. So to do this, what we're going to do is, see this part here. What does that equal? What does 1 squared plus 2 squared all the way to k squared equal? It's basically the p of k, isn't it? It's this one here, k over 6 into k plus 1, 2k plus 1, and you want to prove that it equals all of this here. We can start multiplying straight away if you want. Oh, wait. I forgot one thing. I forgot the k plus 1 squared, alright? Now, there's a really cheap way of doing this, right? I think the fraction is generally considered a problem. Okay? So what we're going to do is something like this, k plus 1, k plus 2, 2k plus 3, all over 6. Why is it all over 6? Can anybody tell me? They're all being multiplied. And a junior cert example would be if I had a half multiplied by 5 multiplied by 4. It's the same thing as 1 by 5 by 4 all over 2. The minute I put a plus in here, all bets are off. It's 5 over 2 plus 4. Is that right? So it's only when they're all multiplying. So upon completion of that, what I'm next going to do is going to modify this. I'm going to put a 6 up here and a 6 down there. Happy enough with that? Going to multiply this out. K times that is going to be k squared plus k into 2k plus 1 all over 6 plus 6 times square out k plus 1 squared plus 1. Oh wait, there's a really easy way to do this. I'll show you the quick way. You have two choices. You can multiply out both sides and just show that they equal each other. You're going to get a cubic function on both sides. Just pretty much multiply them both out and keep them over 6 and make sure that they equal each other. Now the second way I can see it doing this is like this. See the way that's k plus 1 squared? I'm going to change that into k plus 1, k plus 1. What do they both have in common? They have k plus 1 and 6 in common. So if I take out k plus 1 over 6, what am I going to be left with? I'm going to be left with 2k plus 1. I'll underline it in black. 2k plus, yeah, you're right. K times 2k plus 1. Now just stop there for a minute. What happens if I multiply this back out? I get everything that was there. Can you see it? K plus 1 over 6 times k into 2k plus 1. It's exactly the same as what's in the black box. Okay? And then on the other side, I'm going to have plus the k plus 1 and the bottom 6 are gone. The two of these are gone. And what that leaves left over is the 6 and the k plus 1. Okay, personally, you probably just better off multiplying them both out rather than doing. This is just the quickest way. What I'm going to do next is k plus 1 over 6. I'm going to multiply this out. 2k squared plus k plus 6k plus 6. And then I'm going to get k plus 1 over 6 into 2k squared plus 7k plus 6. There's a reference number here, the reference number being 12, which is the same thing as 3 multiplied by 4. So it's going to be, if I just factorize this in the corner, it's going to be 2k squared plus 3k plus 4k plus 6, k into 2k plus 3, and then the other one is going to be Was it plus 2 into 2k plus 3? And that's going to be k plus 2 into 2k plus 3. Factorising. Okay, assuming we're all taking care of that at this stage. And then all I have to do is replace it in k plus 2, 2k plus 3. Alright, and what was the left hand side again? There it is there. Same thing, isn't it? So you've proved it. Your usual spiel, true for p of k plus 1, if p of k is true, hence by the principle of mathematical induction, p of n is true. I'd advise most of you just to multiply it out. Just multiply it out and add it all together. Would you like me to multiply it out?
No,
we good? Okay. This one here, reasonably easy, but we're going to make... I've started doing these sort of like a bubble diagram nearly, okay? Like this. So you start off year 1 with €45,000. You then travel over here and you have your new amount at the end of, so that's the start of year 1. And then, what's this going to be? Year 1 end, okay? So year 1 end is, you got to add on how much? Multiply by 1.06 and what you get? 47,700. You do nothing between the year 1 end and the year 2 start. Oh, do you? Sorry, you do take out minus 7,000. So take out minus 7,000. Sorry?
40,000.
Oh, yeah. You take out how much?
7,700.
Okay, and why? Oh, it says it there.
Yeah.
Your 7,700 is taken out. You're back to 40,000, and this is the start of year 2. Then you multiply that by 1.04, and you're left with 41,600 at the end of year 2. And then at the end of year 2, we take away a certain amount of money, don't we? Minus W. We have no idea what's in this bubble here. That's the start of 3. And then it gets multiplied by, because you get 3% added on. And at the end of year 3, 37, was it? 37,080. Now, you multiply the number by 1.03 to get 37,080. The reverse process is dividing by 1.03. And you divide by 1.03, what you get? 36,000. Okay. Now you have your 41,600 from the end of year 2 and your 36,000 at the start of year 3. What did we take away to make that happen? 5,600. That's a pretty easy one. Okay. Just gotta keep track. I started using that sort of diagram. Next bit, all the way up, and then you just reverse the process to find what you're looking for. Okay. Next one. We did this before, right? If it's continuous growth, it's a positive party. Okay. P to the R T. If it's depreciation, it's a negative party. So P to the minus RT. Okay, that's how we remember it. Now, this is depreciation, and keyword, continuously. Don't assume it's continuous unless it tells you it's continuous. Okay, so all we got to do now is your P is what, guys? Oh, sorry, is it A, or what's the current? Is it F, isn't it? F equals. So your F is your final amount, which is 72,275. Our P is our 110,000. Our E is just the E function, 2.718. R, we don't know, it's the whole point of the question. 7 years, so R times 7 minus 7R. Now, step 1, Divide the 72,725 by 110,000. And you get ln, oh sorry, not there yet. You get e to the power minus 7r. Now, as everybody knows, I've tried to drill this into you as much as I can. Everybody listening? When the variable you're looking for is in the power position, what must you do to both sides? Log both sides, okay? So ln this one. Now, you're going to have a rule for this. Your rule is the power rule of logs, which brings the minus 7r to the front. So minus 7r ln a. And what is ln a? 1. So it's minus 7r. Now, what we're going to do with this number here is our ln, our 72,275, and then we're going to divide that by our 110,000, and then close your bracket, and you get minus 0.42. I think it's safe enough to say minus 0.42, okay? Or minus 0.42. Divide that by minus 7. Just keep it going in your calculator so you don't introduce any negative numbers. And we get minus 0.06 equals r. 0.06 equals r. R was 6%. I think most of you did okay there. Okay? So I was going for 10 marks. Moving on. This one here, okay? Complex numbers. So this one here, okay? Express it in complex form. So to express this in complex form, you're going to see the angle of W here. Now remember, you're taking the angle relative to the right hand side of the x-axis, okay? Now, what's going to happen first of all is this here is root 3. So the angle we're looking at here is root 3. This one here is 1. That's angle A. It's tan A equals root 3. Inverse that, you're going to get A equals 60 degrees. So because this here is 60 degrees, we now know that the angle going to there is 120. Are we happy with that? 120. Next, you use Pythagoras' theorem to find the r value, or the modulus value. R squared equals root 3 squared plus 1 squared. R squared equals 4. R equals 2. Okay, so R is going to get you 2. Okay. Now, once you're done with that, what you're going to do next is you are going to use your formula for, the r cos theta plus I sin theta. You're going to get 2 into cos 120 plus I sin 120. Going for 5 marks only. Okay. Next question. Z squared equals minus 1 plus root 3i. This Z squared is going to be equal to 2 cos 120 plus I sin 120. Okay, and it says solve the equation. Okay, so it says solve the equation. Now, you guys got mixed up between two different questions. Now let me explain the mix up, okay? This is a solve question. The solve question automatically has the 360n involved. What some of you guys did was this. W equals minus 1 plus root 3i from the first part of the question, doesn't it? Some of you guys tried to find W squared. And what W squared would be is this complex number here, the cos 120 plus I sin 120. And what you do there is it's dug that one to be squared, and that's where some of you guys got your 4 cos 240 plus I sin 240 from. You're completely answering the wrong question there. Blue question is W is this, find W squared. In the second question, it specifically states that they're using Z Z equals 1 plus root 3I. It's basically saying that Z squared equals W. Okay, it's not asking for W squared. So that answer is long gone. So it's what we've always done for the solved questions. Okay, part 1, change it with your 360n attached. So it's going to be cos 120 plus 360n plus I sine 120 plus 360n, close bracket. Okay, now that's Z squared. What do I tell you to do with the squared then? You're in a test, you don't want to rewrite this. Power of a half on the outside. Okay, that now does two things. The half gets attached to the power to become 2 to the power of a half and 2 to the power of a half. Anybody? Root 2. 2 to the power of half is root 2. We're good with that? Okay, anything to the power of half is the square root of that number. Now, what's the second part? What's the second effect of the power of a half? The angles get halved. So the angles get halved is going to be cos 60 plus 180n, and then plus I sine 60 plus 180n. Okay, you go downwards. You go, okay, I need two answers. I need the answer when n equals 0, and I need the answer when it's n equals 1. How do I know it's only two answers? Z squared. Z cubed, 3 answers. Z 4, 4 answers. Okay, 2 answers only. Z1 equals root 2. What's cos 60 plus 180? Cos 240. Will somebody do that on the calculator for me while I'm waiting? Oh, sorry, my bad. I did the first one. It's sorry, cos 60 sine 60 because n equals 0. I was doing the second one, wasn't I? Which is root 2 cos 240 plus I sine 240. Okay. So, put that into the calculator. Will somebody tell me what root 2 cos 60 is?
Root 2 over 2.
Root 2 over 2. Oh yeah, which is the same thing as we'll just leave it as calculator gives it. Root 2 over 2, and then I sine root 2 sine 60. Root 6 over 2. I, and then after that root 2 cos 240. Grand. And then after that sine 240. Sine 240.
Minus root 6 over 2.
Minus root 6 over 2. Okay. So there you go, full marks. There's different ways of writing those thirds, okay? The first thing to remember is I'm going to make up a complex number for you now, okay? And I'm going to make it undergo some of these transformations you're talking about. So I'm just going to pick a random number, like I'm going to make this one here, right? What do we say, about 4 cross 3 up?
Yeah.
I'm going to call one of them Z equals 4 plus 3I. Okay? Now, I times Z, what would I times Z be? Multiply this by I. So, 4I plus 3I squared, and you guys know that that's the same thing as minus 3 plus 4I. So, if you imagine that this one here was 4 plus 3I, you multiply it by I, and all of a sudden it ends up as minus 3 plus 4I. What it's undergone, when you multiply by I, you give it a 90-degree rotation. Do you understand that? So in this exam, you could have drawn this back up here. You could have drawn a straight line between both of them, and you could realise which ones are at 90 degrees to each other. You'll also notice that the modulus length is maintained. The modulus of this is 5 when you do Pythagoras' theorem. When you do Pythagoras' theorem for this one, the modulus of I said is also 5. They are the same lengths. If you went into your exam and just grabbed out a ruler and just like measured them both out, you'd find that they'd actually be the same length as each other, like what, roughly 6 centimeters each. right, you'll find that be the same. Now,
Is it so?
anytime you multiply by I,
Yeah, but does it always go anti-clockwise?
yes, anti-clockwise for I. Sure, why not check it out? I say it'd be clockwise, so let's give it a look. So I will always send it anti-clockwise. Let's see what happens when we multiply by minus I. Minus IZ will give us minus 4I, and then minus 3I squared, yeah? And that will be 3 minus 4I. So 3 minus 4I down here. Exact mirror image of the one we just had there a second ago through the origin. Mirror image through the origin, 90 degrees anti-clockwise. You realistically just make up a number and test it out and see what happens to it. And then you can almost teach it back to yourself what's actually going on. Okay? Because it's very hard to remember, so just make sure you make up your own number. Now, if I did another thing, given that IZ makes it turn anti-clockwise, what would 2IZ do? It would turn it anti-clockwise and double its length or double its modulus, right? So, with this in mind, what we can do next is this. Cool. That's 4 plus 3I, 4 minus 3I. Okay. Now, 4 plus 3I minus 3 plus 4I. Okay. Set 4. Okay, so we're just going to get rid of this here. So we know that this one here is going to be Z1. This one here is going to be Z2. Reason being, 90 degrees and the same length. Z3 equals KZ1, where K is an element of R. What does K do to Z1? It will either make it smaller or bigger. It'll either make it smaller or bigger. If K is smaller than 1, makes it smaller. If K is bigger than 1, makes it bigger. What happens if K is negative? Let's find out. 4 plus 3I. It is, but to remember that is hard. There's so much to remember. So what I'm arguing is you have a couple of choices here, right? Your choice number 1 for K is it's a number smaller than 1. If it's a number smaller than 1, let's say for argument's sake a half. When I multiply this by a half, it's going to be 2 plus 3 over 2 I. Your modulus is halved, but your direction is maintained. So hence Z3 is half of Z1. That makes sense? Z3 half of Z1. So that means your K value is going to be a half, because you can just measure it using your ruler. This will be 3 centimeters, the full thing will be 6 centimeters, you know, it's a half. Or just by I, it's a half. Okay? Now that that's done, what happens if K is a number bigger than 1? What happens then? So if I said it was 4 plus 3I to begin with, if we multiply that by 2, we get 8 plus 6I, which is twice as long as the original. If I say that K equals minus 2, we automatically know it's twice as long. But multiply 4 plus 3I by minus 2 and you get minus 8 minus 6I. And it goes twice as long out the other side. Is that right? Now, finally, you can almost say by process of elimination the last one is Z4. But we're going to go a bit deeper than that, okay? When you add two complex numbers together, I'm going to make up an example for two complex numbers, okay? Two complex numbers could be, let's go with minus 3 plus 4I. Is, call that Z, we'll just call it Z10, right? And this one here, Z10 plus Z11. And Z11 will be, I don't know, 2 plus 3I maybe. Okay? Oh, yeah. Sorry guys, I'm just making this question up in context here, okay? Do you see the way this line here, this one here has a larger x value than Z3. Does everybody agree with that? And it has a larger y value. So I'm going to make up that Z10 is minus 3 plus 4, right? I'm going to make up that Z11 is, I don't know, 1 plus, I I don't know, 2i. When you add them together, what happens? The result is a negative minus 2, and their heights is their two I values added together to make 6. Okay, now look at this. If I was to break this up here, okay, into its x and y components, look what happens when I move the y component over here. You're increasing the y component by the height, and then look what happens when I move the x component over. It fits exactly into set 4. So set 4 is the result of set 2 plus set 3, moving it across and upwards. Also known as a translation. Remember what translation is?
Yeah.
If you have a complex number and you add another complex number onto it, you just move it across by that complex number. So in effect, what we did here was when you add complex numbers together, you're doing a translation. So let me show you something else. See set 3 here, just going to have it in green here. All what it is you bring that green one over here, and there's your translation from point to point, because you added it on. Okay? Yes?
You know the inward and outward spiral thing you were talking about?